Okay guys, so in today's math lesson, we are learning how to display or to represent measurement data on a line plot. So what I have here already drawn on the board is a chart of different measurements. We'll call them inches. Maybe I measured 10 different objects and I measured how many inches, like 10 different beads, something small. And I measured the size of each one. So I have one that is 1 inch, another that is 1/4 of an inch, another that is 3/4 of an inch, one that's 1/2 inch, another that's 1/2 inch, one that's 3/4 of an inch, another that's 3/4 of an inch, and another that's 3/4 of an inch, one that's 1/4 of an inch, and another that's 1/4 of an inch. Now, what I want to do is I am going to show this data on something called a line plot. So, step one of creating a line plot is to basically draw something that looks like a number line. So, I have an arrow over on this side. Oops, actually I need to give myself more room, so I'm going to erase and I'm going to make it a little bit lower. And you'll see why as I keep going. So I've got my arrow on one side and my arrow on the other side because remember that shows that the number line keeps going. Now we have all numbers, all measurements that are between 0 inches or nothing and 1 inch. So that means all of my data is going to be plotted between 0 inches and 1 inch. Now I need to create a number line with what I have. Most of my fractions have a denominator of 4. So that means I'm going to break this number line into fourths. Remember, to break it into 4 pieces, I don't have 4 tally marks. I have 4 sections. From 0 to the end of this first section is 1/4. Then I add another section, which I know from 0 to this tick mark is 2/4. And then I add another section, which is 3/4, because from 0 to here shows 3/4. And then I have my 4th piece, which is equal to 4/4. 1 or 4/4. So I have 0, 1/4, that's one piece. 1/4 to 2/4 is another piece. 2/4 to 3/4 is the third piece, and then 3/4 to 4/4 is the 4th piece. Now, because I have, numbers that are the same up here, I'm not going to put dots on the line. What I'm going to do is I'm going to put an X every time I come across a measurement. So, let's start with this. Well, I have 1. So I'm going to put an X above the 1 inch mark. Now I'm done with that. Now I have 1/4. So I'm going to put an X above the 1/4 mark. 3/4, well, I'm going to put an X above the 3/4. 1/2 and 1/2. Well, those aren't set up like fourths. So what I have to do is I have to get them to have a denominator of 4, which I know all I have to do is find an equivalent fraction that has 4 as the denominator. So 1/2 equals something with 4 as the denominator. Well, I know from doing equivalent fractions that I just figure out what I have to multiply the numerator and the denominator by. I know I have to multiply 2 by 2 to get 4. Whatever I do to the denominator, I also do to the numerator. 1 times 2 is 2. So that means 1/2 is equal to 2/4. So, and I do have to show that. I have to show that work every time this happens. So now, I know that 1/2 is equal to 2/4, so I can put an X above my 2/4. Oh, and now I come to another 2/4. This is the first time that we've repeated. Well, I'm not just going to ignore it because I already have an X. I'm going to go ahead and put another X right on top. So instead of having 1 X above each one, now I have 2 X's above 2/4. Now let's keep going. 3/4, well, I'm going to put another X above 3/4. 3/4 again, so I'm going to put another X. 3/4 again, I'm going to put another X. Now 1/4, so I'm going to go over here and I'm going to put another x above 1/4. And then my last one is 1/4, so I'm going to put my last x above 1/4. And so the purpose of showing a chart like this is that sometimes you need to know, okay, which length of bead do I have the most of? Well, I can easily look at this chart and see that I have 4 x's above 3/4, while the rest have 3, 2, or 1, so that means I have the most of the bead that is 3/4 of an inch long. If I wanted to know which bead I have the least of, well, I can quickly see that the 1-inch bead is the bead I have the least number of. So the purpose of a line plot is to show how much of each length you have. So everything we're doing today is going to be just like this. There will be times where you can just pull the measurement straight from here. There will be times, like in the case of this 1/2, where you have to find an equivalent fraction that can fit on the line. So what we're going to be doing today is you're going to be learning how to draw this line plot. So exactly how many pieces you need to break it into, how you need to label each piece, and so on. And then you'll also learn how to plot it. Okay, so let's go ahead and look at the sentences under the title. Read along with me in your head while I read out loud. You can represent measurement data for fractions of a unit in a line plot. The line plot's number line will look like a ruler. Well, we kind of saw that. It looked like a ruler because we had 0 inches and 1 inch, and we know that in between 0 inches and 1 inch, we have a 1/4, a 1/2, which is equal to 2/4, and a 3/4 mark. We're actually going to be looking at a few more in this case as well. So let's go ahead and look at example 1. Okay, so everybody finger or pencil on example 1. This problem will walk us through step by step exactly how to make and then show data on a line plot. The science room has a collection of bugs. Each bug's length is measured to the nearest 1/8 of an inch. Make a line plot to represent the data. So over here on our chart, it says the measurement data are shown in a tally chart. So over here we have our chart. We have the title, which is bug length, which means that each of these tallies tells exactly how many bugs were this length. And we have 1/8 of an inch, which is just half of a 1/4 of an inch, or 1/4 of an inch, which we can see up here, because we know, go ahead and label these, from 0 to this first tick mark is 1/4. From 0 to this second long tick mark is 1/2. And from 0 to this third tick mark is 3/4. So that means in between each of these 1/4 pieces is an 1/8. All of our measurements are in 1/8, so that means our number line is also going to be broken up into 8 pieces. Again, I know this is in your book, but go ahead and draw over it with me. So we've got our number line, which has an arrow at each end. We start at 0. None of our measurements are greater than 1, so we're going to stop at 1. All of our measurements have a denominator of 8. Now remember, not just like our first anchor chart, not all of our measurements might have the same denominator, but you're looking for the denominator that you see most often. In this case, we only see 8s. So that means we're going to break this number line into 8 equal pieces, and each piece will represent an 8. So we have 1, 2, 3, 4, 5, 6, 7, and 8. So 8 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8. We know that each of those tick marks stands for 1/8. So we've got 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8, which is equal to 1. Okay, so now you guys have drawn this, and even though it was already written for you, you went over it with your pencil. Now we're going to go ahead and down here. Step 2 is place an X above each measurement every time that value occurred. So you're not just looking and say, oh, there's no 1/8, there's definitely some 2/8, definitely some 3/8, and you're not just putting an X above the values that occurred. You're also putting them above each time. So if we look at this chart, we see that there are no bugs that are 1/8 of an inch. So we're going to put no X's above the tally that's labeled as 1/8. Now if we go to 2/8, we see that there are 2 bugs that are 2/8 of an inch. So we're going to put 2 X's above 2/8 of an inch. Now you don't have to redraw the number line down here, but you do need to go over the X's with me. Now if we look at 3/8 of an inch, we see there was 1 bug that was 3/8 of an inch, so we're going to put 1 X. For 4/8 of an inch, there were 2 bugs, so we'll go to 4/8 and we'll put 2 X's. For 5/8 of an inch, there was 1, 2, 3, 4, 5, 6. So that means we're going to put 6 X's above 5/8. 1, 2, 3, 4, 5, 6. For 6/8 of an inch, we have 1, 2, 3, 4, 5 bugs. So we're going to put 5 X's above 6/8. 1, 2, 3, 4, and 5. Now for 7/8, we have 1, 2, 3, 4. So above 7/8, we're going to put 1, 2, 3, 4 X's. And then above 8/8 of an inch, which we know is the same as 1 inch, we have 1 bug. So we're going to put 1 X. So we should have 1 X for each item that was measured. There were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 bugs in all that were measured, which means that we should have 21 marks on this chart. 1 for each time we have a bug. So each bug is measured. That's why we have more than 1 X above some of these numbers or these measurements. So we can look at this problem and we can see that the greatest amount of bugs, without even having to look at the chart, we can see that the greatest amount of bug length, the length of bugs, the length that had the greatest amount of bugs was 5/8 of an inch. So most of the bugs were 5/8 of an inch. The next one is 6/8 of an inch. The bug lengths that appeared the least were the 3/8 of an inch and the 8/8 or 1 inch. 1/8 there were no bugs, so we would not even include that. 0, we should never have an X above 0 because something that is 0 inches doesn't exist. Because there's nothing that we can measure with inches that would be 0 inches. Okay, so now let's go ahead and go on to example 2. Okay, so finger a pencil on example 2. This is an example of another type of problem we will be coming across today. This problem we will not be creating a line plot, but we will be using the information on a line plot to answer. It says, refer to example 1. Find the difference in length between the longest and the shortest bug. So what that means is we're going back to the chart and we are finding the length of the longest bug, which in example 1 was 8/8. So the longest bug was 8/8 of an inch. And then the shortest bug was 2/8 of an inch. Remember, 1/8 is not the length of the shortest bug because there were no 1/8. There were no bugs that were measured at 1/8 of an inch. So the longest bug was 8/8 and the shortest bug was 2/8. Now remember, when we're finding the difference between two things, that means we are subtracting. So all we're going to do here is we are going to subtract like fractions. 8/8 minus 2/8. They are like because they have the same denominator. So we know to solve a subtraction problem or subtracting like fractions problem, we have steps. Step 1 is subtract the numerators as you normally would. 8 minus 2 is 6. Step 2 is the denominator stays the same, so we have 6/8. But remember, step 3 is put in simplest form. 6/8 is not in simplest form, which we can tell right away because both numbers are even. So this is one where we can figure out the greatest common factor by just using basic facts. And the greatest common factor is 2. Remember to always show division by the greatest common factor. 6 divided by 2 is 3. 8 divided by 2 is 4. So that means the difference between the longest bug and the shortest bugs in the collection is not 6/8 of an inch, but 3/4 of an inch. So that's all you have to do when you come across a problem like that. Look at your data, figure out, okay, this is the longest one and this is the shortest one, and then subtract. That's all you have to do. Okay, so now let's move on to the guided practice. Okay guys, so now you should be looking at the guided practice. The directions say for exercises 1 and 2, use the tally chart shown. So that means what we're doing is we're using this tally chart to figure out these answers. So number 1 says, the tally chart represents the widths of buttons collected by Bella's mother. Represent this data in a line plot. So that means each of these tally marks stands for one button that is that length. So we have buttons that are 1/8 of an inch, buttons that are 3/8 of an inch, buttons that are 4/8 of an inch, buttons that are 5/8 of an inch, and buttons that are 7/8 of an inch. If it is not listed on this chart, that means there were no buttons that were that size. So I can already see we don't have 2/8 or 6/8 or 8/8, which means I will have no X's above 2/8, 6/8, or 8/8. But above 1/8, I will have 1, 2, 3, 4, 5, 6 X's. So there are 6 buttons that are 1/8 of an inch. So I'm going to put 6 X's here. 1, 2, 3, 4, 5, and 6. Make sure that you are being neat so that you don't get confused about which tally you're putting the X above. Okay, I'm going to skip 2/8 because I know, and I'm going to go ahead and cross that out to show that I already finished it. I'm going to skip 2/8 because I know that there are no buttons that are 2/8 of an inch, and I'm going to move to 3/8. There are 1, 2, 3 buttons that are 3/8 of an inch, so I'm going to put 3 X's above. I'm going to make sure that I am neat so that I don't accidentally get confused and think I'm putting it above 2/8 or 4/8. Done with 3/8 of an inch, so now I need to see how many are 4/8. There's only one button that is 4/8 of an inch, so I'm only going to put 1 X above 4/8. And now I'm done with it. Next is 5/8. There are 1, 2 buttons that are 5/8 of an inch, so I'm going to put 2 X's, 1 and 2, above 5/8. Now I know that there are none that are 6/8, so I'm going to skip that. And then I'm going to see how many are 7/8. Oops, I forgot to cross out 5/8 so that I know I was done with it. There are 1, 2, 3, 4 buttons that are 7/8 of an inch. Whoops, I only did 2. 1, 2, 3, and 4. And now I'm done with that. I know that there are none that are 8/8 or 1 inch, so I'm done. So that is my button chart. I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 X's because that's how many buttons I have. So let's count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have an X for each button, so I'm good. And I've put them in the right place because I was careful and I made sure. Now, what I'm going to do is I'm going to ask you a couple questions about this problem that are not up here. So, which button do we see, which length of button do we see the most of? Well, let's look at our chart, and we can see that the 1/8 of an inch button is the one we see the most of. Which buttons do we see the least of? We're not going to say 2/8, 6/8, or 8/8 because we don't see any of those. So it's not that we don't see the least amount of buttons, we see none. None and least are not always the same. So the buttons that we see the least of is this button that is 4/8 of an inch because there's only one above it. It's not 2/8, 6/8, or 8/8. It is 4/8 because there's only one X above it. So that means there is a button that's 4/8, but there's only one, so it's the button we see the least of. Now let's do this practice. So let's see. You have some room above the speech bubble. So number 1 1/2 is, let's see, what, make sure you're writing this, is the difference between the longest and shortest button. Make sure you write that because you are going to solve that. Well, we know from example 2, we take the length of the longest button, which is 7/8, and we subtract the length of the shortest button, which is 1/8. So the longest button is 7/8 of an inch, the shortest button is 1/8 of an inch, so we are going to subtract. Well, step 1, subtract the numerators. 7 minus 1 is 6. Step 2, denominators stay the same. Step 3, check for simplest form. 6/8 is not in simplest form, so I'm going to divide the numerator and denominator by the greatest common factor, which is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So that means the answer is 3/4 of an inch. Make sure you have that because you will see problems like that, and I just wanted to get one more done in there. Okay, number 2. This is a different problem. We haven't seen anything like this before. But when you think about it, it's pretty easy to solve. Suppose the buttons that were 3/8 of an inch wide were laid in a row touching. How far would that row extend? So all that means is we're taking those 3 buttons that are 3/8 of an inch, we are putting them together like this, and then we are measuring how long this point to this point is. All we have to do here is add 3/8 3 times. So 3/8 plus 3/8 plus 3/8, because each of these buttons is 3/8 of an inch. So that means from here to here is 3/8 of an inch, from here to here is 3/8 of an inch, and from here to here is 3/8 of an inch. So we're just going to put it together. Well, even though we have 3 add-ins, we're still going to solve it the same way. We're going to add the numerators. 3 plus 3 is 6, plus 3 is 9. Our denominator stays the same. Well, we don't have to simplify, but we have an improper fraction. So we do have to turn it into a mixed number. So we're going to go to the side. We're going to divide 9 by 8. 8 goes into 9 once. 1 times 8 is 8. 9 minus 8 is 1. Our whole number is the quotient without the remainder. So 1. Our numerator is the remainder. And our denominator stays the same. So that means all 3 buttons laid end to end are 1 1/8 of an inch. And that's all you have to do to solve that. You could have also said 3/8 times 3, because you're repeating that measurement of 3/8 3 times. It would have given us the same exact answer. Okay, so what we're going to do is we are actually going to do numbers 3 through 5 together. And then I'm going to explain how to solve number 6, but we're not actually going to do that together. Okay, so let's go ahead and look at number 3, 4, and 5 together. Okay, so we're going to look at numbers 3 through 5 together. I know it's hard to read, but the only way I could fit them all up here was by making it small, but you do have it right in front of you, so you should be able to follow along that way. So it says for exercises 3 through 6, use this table shown. Number 3 says the frequency table represents fractions of an hour Sonia studied each evening over the last 12 days. Represent this data in a line plot. So that means each of these 12 boxes represents one day, and that's how much time Sonia spent studying. So the first night she spent 1/4 of an hour studying. The second night she spent 3/4 of an hour studying. The third night she spent 1/2 of an hour studying, and so on. So what we're going to do is we're going to do this kind of like, let's see, the problem that I did on the board before we even started. So as we go, we already have our line plot, our number line drawn. Most of our times have a denominator of 4, so they broke the number line into 4 pieces. Now we're going to go through, they already told us that 2/4 is the same as 1/2, so if we come across 1/2, or anything with a 2 as a denominator, that means we don't have to change it, we can just look at what they have here. We don't have to turn it into an equivalent fraction with a denominator of 4, because they've already done it for us. So we're going to start, we're just going to go through, I'm going to put an X above the time that's shown, and then I'm going to, over here, and then I'm going to cross this out so I know I'm done with it. So my first day is 1/4. So now I'm done with that. The next day, she spent 3/4 of an hour. The next day, she spent 1/2 an hour, which is the same as 2/4. The fourth day, she spent 1/4 of an hour, so I'm going to add another X to 1/4. The fifth day, she spent 1/2 of an hour, so I'll add another X there. The sixth day, she spent 3/4 of an hour, so I'm adding another X. The seventh day, she spent 1/4 of an hour. The eighth day, she spent 1 hour, which is the same as 4/4. The next day, the ninth day, she spent 1/2 an hour. The 10th day, she spent 1/4 of an hour. The 11th day, she spent 3/4 of an hour. And then the 12th day, she spent 1/2 an hour. So there were 12 days that she studied. So that means I should have 12 X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so now that I've filled out my line plot, let's go ahead and look at this chart right here. Which time interval was least frequent as a study time for Sonia? So that means which amount of time did she study for, the least times? So, in this case, 1 hour, 4/4 or 1 hour is the time interval that she studied the least frequently. Because that question is not asking us what is the shortest amount of time she studied, which would be 1/4 of an hour. It's asking which interval was least frequent as a study time. We know this because there is only one X above 1 hour. So we know it was the least frequent study time because there's only one X above it. It's not asking what is the shortest amount of time she studied. So that's what I mean about making sure that you are answering the question being asked. Because I can guarantee you that if we had not gone over this, some of you would have answered this question as 1/4 of an hour. But that's not correct. It's not asking what is the least amount of time she studied. It's asking which time interval was least frequent. So that means frequent means how many times do you see it? Well, I only see 1 hour once, so that means it was the time interval that was least frequent. Okay, now number 5. What is the difference in total time spent studying during the 3/4 of an hour time interval and the 1/2 of an hour time interval? Well, that's just like that question, like example 2 and like number 1.5 on the guided practice. They're saying what is the difference in time between 3/4 of an hour and 1/2 of an hour. which means that we have to say 3/4 minus 1/2. However, those are not like fractions. So we can't just say, okay, 3 minus 1 is 2, and then 4 and 2. We know we have to keep the denominator the same. Well, we have two different denominators, so which one are we going to use? What we have to do here is just like what we had to do in the problem I showed on the board, where we had to change those 1/2s so that they had the same denominator as the rest of them. So what I'm going to do is I'm going to take my 1/2 and I'm going to change it to a fraction that has a denominator of 4. I know that I have to multiply 2 by 2 to get 4. Whatever I do to the denominator, I do to the numerator. 1 times 2 is 2. So that means 1/2 is equal to 2/4. Well, I can subtract 2/4 from 3/4. 3 minus 2 is 1. The denominator stays the same. So that means the difference in total time between the 3/4 of an hour and the 1/2 of an hour is 1/4 of an hour. So all you do when you have a fraction, when you're subtracting fractions and one of them does not have the same denominator, make them so that turn them into fractions with the same denominator. Then you can subtract them the regular way, like we do with like fractions. Okay, now number 6. I'm going to start it for you, but you're going to finish it. It says, what is the total time Sonia spent studying over the last 2 weeks in minutes? What is the equivalent time in hours and minutes? So what that means is we have to take each of these times and turn them into minutes. All you do there is we're trying to say, okay, 1/4 of an hour equals how many minutes? Well, we know how to solve that. All we do is we know hours are bigger than minutes, so we're going from big to small, which means we start with what we know, and then we're going to multiply it by the number of minutes in an hour. Well, 1/4 times 60, we know we multiply the numerator by the whole number, and then the denominator stays the same. Well, that is that's an improper fraction, so that means we need to turn it into a mixed number. 4 goes into 60. Well, 4 goes into 6 once. 1 times 4 is 4. 6 minus 4 is 2. Bring down the 0. 4 goes into 20 5 times. 5 times 4 is 20. 20 minus 20 is 0. So that means 1/4 times 60 is equal to 15. So 1/4 of an hour is the same as 15 minutes. Now what I'm going to do is I'm going to go to this chart, and every time I see 1/4 of an hour, I'm going to say 60 minutes. Because I know in the end I'm going to have to add all of these together. Okay, so I'm done with that. Now next is 3/4 of an hour. So I'm going to do the exact same thing. 3/4 of an hour equals how many minutes? Well, I know big to small. I'm going to multiply. Start with what I know, which is 3/4. Multiply it by the number of minutes in an hour. Multiply the numerator by the denominator. 3 times 60, I know using basic facts and patterns, is 180. My denominator stays the same. I have to turn it into a whole number or an improper fraction, or a mixed number. So, 4 goes into 180. Well, 4 doesn't go into 1, but it does go into 18. 4 times 4 is 16. 18 minus 16 is 2. Bring down the 0. 4 goes into 20. 5 times 4 is 20. 20 minus 20 is 0, which means that 180/4 is the same as the whole number 45, which means that 3/4 of an hour is 45 minutes. So I'm going to go over here, and every time I see 3/4, I'm going to show, oh my goodness, I just realized for 1/4 I wrote the wrong time because it's not 60 minutes, it's 15 minutes. So I'm going to fix that. every time I see 1/4, I'm going to say 15. Now, every time I see 3/4, I'm going to say 45 minutes. And now I have 1/2. So I'm going to do the same thing. I'm erasing these, but you should still have them in your extra sheet of paper. 1/2 of an hour is equal to how many minutes? You should have all of this on your separate sheet of paper. Well, hours to minutes, I'm going big to small, so I'm multiplying. I start with what I know, which is 1/2. I'm going to multiply by the number of minutes in an hour, which is 60. Now I'm going to multiply my numerator by my denominator to get, by my whole number to get 60. Denominator stays the same. That's an improper fraction. So I need to divide my numerator by my denominator. 2 goes into 6 3 times. 3 times 2 is 6. 6 minus 6 is 0. Bring down the 0. 2 goes into 0 0 times. 0 times 2 is 0. 0 minus 0 is 0, which means that 60 halves is equivalent to the whole number 30, not 20. Which means that there are 30 minutes in half an hour. So every time I see 1/2, I'm going to say 30 minutes. And now all I have left in 1 hour is 1 hour. Well, I already know from my conversions that there are 60 minutes in 1 hour. Now, to figure the total amount of time Sonia spent studying over the last 12 days in minutes, all I have to do is add these all together. I'm going to let you do that. And then the second part, which is what is the equivalent time in hours and minutes? That's where your reasoning skills are going to come in. You will do conversions, but that's where your reasoning skills are going to come in. So for number 6, I've already done most of the work for you to where you can easily figure out how many minutes she spent studying in all. The second part, what is the equivalent time in hours and minutes? That is a reasoning problem, and I know that you can solve it on your own. You just have to use your math reasoning skills. So you know how to convert minutes to hours, and then what are you going to do with those extras? Remember, think about the lesson where we did time, where you were given something like 2 hours and 15 minutes, and you had to figure out how many minutes. You're going backwards. You're going from the total number of minutes to the time in hours and minutes, instead of going from the time in hours and minutes to minutes. So you're just going backwards of what you normally do. Okay, now before you begin, let's go ahead and look through the rest of these problems. Let's see, number 7 and 8 and 9 is just like what we just did together. Numbers 10 and 11 are both reasoning and critical thinking. That means you're learning what you use today to figure out how to solve a problem that we haven't seen yet. And you're using what you learned today along with what you already learned to come up with a new answer, which is critical thinking. Now look at the homework. Number 1, you're going to use that line plot in the homework helper to solve. Numbers 2 and 3 on the back, you're using that chart to create a line plot and then to solve the problem in number 3. Let's see, number 4, you're going to imagine a line plot if you'd like to. You may draw it in that space to the side. Number 5 is a vocabulary question. It's also a little bit critical thinking. Make sure, some of you have really been turning in work with answers that you are not thinking about at all, and it's showing in your grades. Don't let the last quarter be the quarter where you get the lowest grades. Make sure that you put some thought into it. I've been a little upset about some of the answers that I've seen. They're just not your quality of work. So make sure that for number 5 that you have a quality answer so that you don't get a low grade just because you really don't feel like thinking. And then number 4 is multiple choice based on problem 2. Remember, if it says exercise 2, it means number 2. Okay, that's it for math today. If you have any questions, please reach out to me between 1 and 5 today. All you need to do is pay close attention, follow directions, Look at the examples because all of these problems you're going to be solving in the same way as problems we've already done.